So, yeah, students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether or not the student has pierced ears for all 178 people in the class. The two-way table displays the data. All right, so we've got males and females, and that is our explanatory variable, okay? So we do have explanatory and response. So explanatory is going to be male or female. And our response variable is pierced ears, okay, yes or no. And we make a two-way table. So they give us this table. We've got 90 males and 88 females. We've got 103 people with pierced ears and 75 with not pierced ears, a total of 178 kids, okay? So we have to be able to interpret this table and find the probabilities. So suppose we choose a student from the class at random. Find the probability that the student has pierced ears, okay? So probability of having pierced ears, okay? Just out of the total, right? Nothing else. So who can tell me what the probability of having pierced ears is? Jet. Yeah, we have 103 total students out of 178 that have pierced ears. Okay, and I think we are going to do a lot of decimals, you guys, round to about 3 places or so on these. So whatever that would be, but I'm going to leave it like that, okay? And then we have is male and has pierced ears. So both is male and has pierced ears. So this is the probability of male and pierced ears. I don't know how to spell this, so it's backwards on that one. I don't know. Okay? Yeah, this one was wrong. There we go. Okay. So anyways, both occurring at the same time. When it's and, you guys, or means you're adding them, right? But and means both occurring at the same time. So David O, how many are male and have pierced ears? Good. Okay. 19 out of 178. So this guy right here, this number, represents both of them happening at the same time. Okay, and this is the big concept of the day. Is male or has pierced ears. So we did the and, that's both occurring at the same time. Now we are doing the or. So the probability, male or pierced ears. All right. So or means add, right? Anyone have a guess of how I would do this? Cece? So you want to add the 71 and the 84 over 178? Anyone have another idea? Yep, Chelsea?
Do the total male over the total people plus everybody has pierced ears.
So you want to add the 90 and the what? And the 103? Okay, you want to add the 90 and the 103 over 178. That is a good start. Kyle? Yes, that is exactly right. So this is the big concept of the day. So we want everybody who's male, that's the 90 out of 178, and we want everybody who's got pierced ears, the 103 over 178. But we're double counting, okay? We're double counting those 19 people twice. You can't do that. We got to subtract them out. So anytime it's or and they're not mutually exclusive, yesterday they were mutually exclusive, so we just added them together, right? These are not mutually exclusive because we have people who are both male and have pierced ears. So we are going to do, and you want to show your work on these. So we have males 90 over 178 plus 103 over 178 are pierced ears minus the overlap 19 over 178. So it's always going to look like that. Okay, and then whatever our final answer is, and we're good to go. Tyler. instead of doing 90 minus 19. No, I want to see it like this every time. Okay? Even if there are other ways, because that is the definition right here. Right here. This is your formula, you guys. So use it. This is on the AP exam. Write this down. This is called the general addition rule for probability. Okay. So I need to see it like this. So if you have the probability of A or B, again, the word or, not the word and, the word or. We're going to take the probability of A happening. In this case, it was being a male, plus the probability of B happening. In this case, it was pierced ears, minus the probability of A and B. So label this, you guys. This is where both occur at the same time. If the events are mutually exclusive, do you have to do this part? No. If the events are mutually exclusive, what does this part equal? 0. There is no overlap. Okay, that's what we talked about yesterday. All right, so you guys are going to try these in your notes. Okay, so we have a standard deck of playing cards with jokers removed. No jokers. So that means we have 52 cards in 4 suits. You guys remember this? 4 suits. There's clubs, diamonds, hearts, and spades. Each suit has 13 cards with denominations. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. The Jack, the Queen, and the King are referred to as face cards. Okay, so there are 3 face cards in each suit. Imagine that we shuffle the deck thoroughly and deal 1 card. Let's define the events. So they define the events for us. F is getting a face card, and H is getting a heart. I want you guys to try to make a two-way table to display the sample space. We can start in certain places to make it easier for ourselves, okay? So they told us that there was 3. Okay, we know there are 3 face cards that are hearts. There's a Jack, a Queen, and a King. So there are 3 face cards that are hearts. We also should just know how many total hearts are in the deck, right? There's 4 suits, so 52 divided by 4 means there's 13 cards that are hearts. So now we can fill in the not face card by just subtracting. So there are 10 not face cards, okay? Now, you might want to fill totals in as much as you can. Sometimes those are easier, right? So now I can also fill this one in because if 13 are not heart, or 13 are hearts, how many are not hearts, you guys? 39, because they have to add to the 52 here, right? Okay. We can also figure out how many total face cards there are. So the next thing I would do is the total number of face cards. There are 3 in each suit, right? And there are 4 suits. So how many face cards? 12. Which means now we can find this number. Okay, 9, so they have to add to 12, right? And now we can find this middle number because these have to add going this way, right? What goes here? 30, since they have to add to 39. And now we can add down and find this number. So fill in any certain one you know, and then do subtraction, okay, to get the rest of them. And that will help you set these up. All right, let's try another one now that we have that set up. All right, find the probability of F and H. You must say probability of F and H equals, okay? This one doesn't have a lot of work to show, but you do need the P of. Okay. All right, so Donovan, what'd you get? Okay, good. So you should have written this equals 3 out of 52. It's both a face card and a heart. There are 3 out of the 52 total. Okay. And now you guys can do number 3. Explain why the probability of getting a face card or a heart card is not equal to the probability of a face card plus the probability of a heart card. And then use the general addition rule to find the actual answer of the probability of F or H. All right, so Tyler, how come we can't do this? And what's the vocab word? Anybody got a vocab word to explain why, Stacey? Overlap? Nope. Yep, Abby? Yep, that's what I'm looking for. They are not mutually exclusive because of the overlap, all right? Because we have ones that are both. But mutually exclusive, this works. Not mutually exclusive, you have to subtract. So you guys, when you show your work, it needs to look like this. The probability of F or H is equal to probability of getting a face card plus the probability of getting a heart minus where we double counted it, and our answer and our decimal. If you left it as a fraction, that's fine, 22 over 52, okay? Any questions? Everyone good on the general addition rule? Okay, subtract the overlap.